Yesterday we began this lesson on our sum and difference formulas, so today we're going to wrap it up. We looked at one example like this one yesterday, but we'll look at one more example like this, and then we have a third type of problem to look at. So for this type of problem, when we're asked to find a trig function of a sum or difference of two angles and we don't know what those angles are, so there's no numbers involved, we're just going to write out the formula as it is. Okay, so you look at your formula sheet and write out the formula for whatever the thing is you're asked to find. We're asked to find cosine of u minus v, so I look at the difference formulas and I write out the formula according to that sheet. Be careful with your u's and your v's, careful with your handwriting, because it does make a difference what is what. So make sure that you can tell where you've written a u and where you've written a v. And then we're going to take the information about angle u and draw a picture. So it says angle u is between 0 and pi halves, so that'd be 0 to 90. And that our sine, which is opposite over hypotenuse, is 1 over 5. So we need to find the third side of this triangle. 1 and 5 aren't any special triangle numbers for us, so we'll just use our Pythagorean theorem to do this. So 1 squared plus b squared equals 5 squared. So 1 plus b squared is 25. B squared is 24. And we'll want to solve this with a square root. Simplify square roots whenever possible. So a perfect square that goes into 24 is 4. So this is 4 times 6. So that is 2 roots of 6 for the third side of this triangle. There's a positive 2 roots of 6 because it's on the right-hand side. So think about your positives and negatives within your triangle for the sides. Then we want to do the same thing for the information given about angle V. So angle V is between 180 and 270 with an opposite of -5 and a hypotenuse of 13. We can find the third side of that one. This is kind of a special triangle for us with a -12, but if you don't remember that, then you can just do the Pythagorean theorem here. It needs to be a -12 because it's on the left. So think about our negatives in the triangle there. Then we want to go through and find the things required in this formula, so the cosines and sines of u and v, using those two triangles. So the first thing, cosine u, I look up at the u triangle, cosine is adjacent over hypotenuse. And then later on in the formula I need the sine of u, and the sine of that triangle is opposite over hypotenuse, 1/5. Then I need the cosine of v, so I look at the v triangle. Cosine is adjacent over hypotenuse. And later on I need the sine of v, which is opposite over hypotenuse. And don't do any simplifying at this point, even if it's possible, just multiply them together. When we multiply a number that's a root and non-root, we can multiply the outside parts together. So I get -24 square roots of 6 over 65 plus a -5 over 65. There is some reducing that could happen here, but don't do it because right now they have a common denominator, which is good because that's what we need to be able to put together fractions. So we're going to put this all together over a 65. We can't add roots and non-roots, so we're just going to write them both on top of this, and that's as good as it can be. We can't add roots and non-roots, but we can multiply them. Questions?
You can't subtract the 24 and the 5.
We can't because the 24 is connected with the square root of 6. So it's kind of like thinking about the square root of 6 as being like a variable. So if it was negative 24x minus 5, I
Okay.
can't put those together. So it's that same idea. Our third type of problem is going to be to simplify some trig expressions that have sums and differences in them. So the first thing we're going to want to do is apply the sum and difference formula. U means first thing and V means second thing. So I would look up the cosine formula for difference, since this is a subtraction, and write that out, but with the x and the pi in it. So it's cosine x cosine pi plus sine x sine pi. X is a variable, so we can't really do much about that, but pi is a number, and it's a special angle for us. What angle is pi? 180. So what we want to do is think about our unit circle at 180 or pi, and that point on the unit circle is negative 1, 0. And every point on the unit circle represents a cosine and then a sine. So that means that the cosine of pi, which is a part of this problem here, the cosine of pi is negative 1. And the sine of pi is 0. We can't do anything with the x parts because those are variables, so we'll just copy those down. So then cosine of x times negative 1 is just a negative cosine of x. The sine of x times 0, well, anything times 0 is just 0. So this just becomes a negative cosine x. Questions?
Thank you there first.
Yep. Okay, so for this one, this is a sine with an addition, so we're going to look up the sine sum formula. And it says sine of first, cosine of second, plus cosine of first, sine of second. X is just a variable, so we can't do anything about that, but pi halves is an angle. What angle is it? 90. So if we graph out the angle 90 and use our unit circle, that point is over 0 up 1. And that point is cosine comma sine. So that means the cosine at pi halves is 0. And the sine at pi halves is 1. We can't do anything with the x parts, so let's just tag along. Then in the front of this, I have a sine of x times 0. Anything times 0 is just 0, so that whole part really just disappears, and I end up with cosine times 1, or just cosine. Now to tie this to what we learned recently about graphing, the idea is that if we would graph this equation, so let's say it was y equals this, what does that plus pi halves do to our graph? It does shift it in one direction. Which direction? To the left. So, in addition, inside the parentheses with the x is a side-to-side shift, and it goes backwards of what it says. So what this means is I would take my sine graph, and I'm going to bump it backwards of pi halves. The fact that we got cosine as an answer means that if we would do that, it's going to look exactly like the plain cosine graph. Okay? Because they're both just waves, So if I bump that wave over a little bit, they're going to start looking like each other. And this means if I take that sine graph and I bump it back just a half of a pi, it's going to start looking exactly like the cosine graph. Just to kind of connect ideas from our various trig portions here. The homework tonight's been 14.6. Some of you may have tackled some of this already, but the entire assignment will be due tomorrow.